So hello everyone, today we're going to present our project for INFOMATRIX ASIA-2026 and our project is called Multi-Enter Online MOS Algorithm. So my name is Azamat.
I'm Ramazan.
And I'm Asad.
Let's start.
So basically the reason that is standing behind our idea is that in real-world applications, data systems predominantly rely on online algorithms, which in fact work fast and in real time. But however, in computer science and competitive programming, the most powerful and useful program is MOS algorithm. The gap of this MOS algorithm is that it operates only offline. So our hypothesis is that if we adapt this MOS algorithm to online, we would make faster all the works that work right now more slowly than this.
So next is our project goals. First is to design and validate an efficient online algorithm for dynamic range queries. And the second one is to bridge the gap between offline range query optimizations and real-world applications. Like we want to find the way how to use it in real-life transactions and other fields. So how to solve this problem? We've made a new trick which helps us to process all those queries not in offline mode but in online, which is really good idea. So instead of just saving one segment of Mo LR, we save several segments. For example, when we process some query LR not in offline, in online mode, we just check did we create it like less or equal to m of segments. So for example, if we created less than m segments, we can just create new segment of Mo LR where L is equal to L and L is equal to L. But if we already created m segments, we just search some kind of Li segment where the Manhattan distance is minimum. We search such segment and then we just change Li to LR. And it will work really fast.
So let's do it in practice. We have n numbers starting from A01 to A0n. Our query is between L and R, which is to find value of operations starting from L to R. So how can we do it for Q queries?
So how to solve this problem? First of all, we need to know about the algorithm Mo. So what is algorithm Mo? Algorithm Mo is to rearrange these queries from L to R in some order so that the overall time complexity will be lesser. So how we can do this? Let's sort our queries by L divided to some constant B and to R. Which means that first of all, we process the queries when L divided to B is equal to 0. And then we just sort by R. Then we process the queries which L divided to B is equal to 1. And then we just sort by R. So what would be our overall time complexity? So our time complexity for L is, we know that every L we have n divided to the number of constants which is B, and we have Q else, so we multiply it by Q. Then for queries R, we have n to n divided to B. And then so what is our overall time complexity, which is L plus R, is equal to n divided to B by Q plus n divided to B. So it's logically understandable that for B we choose the square root n. So it will be n divided to square root n by Q plus n multiplied by n divided to square n. So our time complexity overall would be square root n plus q, which is our time complexity of algorithm O.
So our research question is that can an online variant of MOS algorithm achieve near offline efficiency without query sorting? And our hypothesis, we hypothesize that maintaining multiple independent sliding windows anchors can significantly reduce amortized pointer movement in online range queries.
So next one is our methodology, how we use this algorithm. So key ideas is to not only save one segment, it's to save a lot of multiple segments of multi-answer, and also how we choose this answer. First of all, we check we have enough answers or not. If not, we just create it. If we already have, we just find the minimum cost fallback and move the closest existing answer. That's all.
Here we can see our implementation of MOS algorithm. Here is two photos. Left one is about query processing logic, and right one is range query. So here we can see how MOS algorithm is implemented in the code and programming.
Yeah, you can see how there is a working update, and also how we choose the most effective one and how we change it at the end.
Analysis, first of all, is works in strict online settings, near offline efficiency, and simple heuristic logic. The second is anchors act as a spatial cache in the query space. Third one is query locality is exploited automatically, and the last one is dynamic anchor placement adapts to work world.
But of course there is limitations. First one limitation of our project is large constant factor due to multiple frequency arrays. Second one is worst case update affects all anchors. So heuristic thresholds require tuning.
So our conclusion is that we showed that a multi-answer online adaptation of MOS algorithm can efficiently process encrypted range queries, suggesting that heuristic window catching is a viable alternative to offline query sorting.
Now our future work is at extensions. Adaptive threshold tuning and application is stream processing engines, and broader impact is technological impact.
But the most valuable one is the cybersecurity, because as we know in banks we have a lot of queries and it's really hard to process it online, and as we know we don't have really good algorithms for this, so this trick can not only use this MOS algorithm in online mode, but also it can make this process fast, so we can find the strange transactions much faster.
And
thank you for your attention.